Today, we are going to learn the quotient rule of exponents. And you all know that that word quotient stands for division. We're talking about the answer to a division problem. So now we're talking about a division problem that involves exponents. So let's talk about the basics over here. And then please stick around at the end of this video to see what we do when we get some crazy, tricky stuff thrown at us. We got a lot going on and we need to know multiple rules in order to solve these. But we are all capable of doing it. Just follow the rules that we've learned. First and foremost, what are we going to do if we have a division problem where my bases are the same? Here we have an a and an a as a base. We have an exponent of m and an exponent of n. So the rule is this. This becomes a to the m minus n. It's kind of like the opposite of the product rule. Okay, the product rule says if we're multiplying bases that are the same, add our exponents. Now we're dividing, so we're going to subtract our exponents. Let me prove to you why this works. Don't just take me for it. You need to look at and understand why it works. 5 to the 5th power is really 5 times 5 times 5 times 5 times 5. 1, 2, 3, 4, 5 times. And I'm dividing that by 5 squared. 5 times 5. I don't know why I wrote a 2. That was weird. Let me fix that. 5 times 5. Quick, easy fix. There we go. So basically, 5 to the 5th power means let's multiply 5 times. 5 to the 2nd power means multiply it by itself twice. Now, what do we know about when we divide a number by itself? They cancel. So if I'm taking a 5 and dividing it by another 5, those cancel out. See you later. Never to be seen again. That 5 is going to cancel out this 5, and we're left with 1, 2, 3 5s. Well, going to the quotient rule, which we just talked about, subtract the exponents. 5 minus 2 would leave me with 3. That is why this rule works. All you're doing is if you realize that you have bases that are the same and you're dividing them, you can subtract your exponents. So what happens if we have two factors here? K to the 8th power times j to the 4th, k to the 3rd, j to the... This is the trick here. I will see kids all the time say 8 minus 3. They're like, oh, Belek, I get this. I understand this. This is easy stuff. And they say 8 minus 3, and they're going to get a 5, which they are correct so far. But then they go to the next part, and they say j to the 4th, and then they just say j to the 4th. You can't do that because there's technically a 1 right there. I would encourage you, when you see a factor without an exponent, put a 1 there. Now you visually see that there's a 1 that you need to subtract and take away from that 4. 4 minus 1 is going to give you a 3. So this would be 8 minus 3 gives me 5, and 4 minus the 1 would give me a 3. There's your basics. That's what you need to know in order to do this. Now you also need to know some other rules with these ones. This one I have basically just the quotient rule. But in this one you need to also know the power to a power rule. If you haven't watched that video, it's the one where it's an old high school picture of me, the thumbnail. It's just me flexing. Go ahead, go watch that video, and that will help you understand how to do this problem. But I'm going to show you how to do it anyway, so stick around. Let's get it started. All right, so I want you to think of these in parts. 12 divided by 4 is one section, and then the A's are a section, the B's are a section, the C's are a section. We're going to go through each and every one of them. Here we go. 12 divided by 4. Focus on that, do that. That's step 1. 12 divided by 4 is 3. Copy it down. Now, a to the negative 1st divided by a to the 5th. You're going to take negative 1 and you're going to subtract 5 from it. If I have negative 1 already and I take 5 more away, I'm going to be left with a to the negative 6th power. Now, hopefully we know what we're doing with our negative exponents. We'll talk about that at the end. Save it for the end. B to the 6th minus negative 1. I am subtracting a negative. And we know subtracting a negative is really adding. So 6 plus 1 would give me b to the 7th. Negative 3 minus 5. Say it out loud to yourself. Make sure you hear it. Negative 3 minus 5. You're going to go further back into the negatives all the way to c to the negative 8th. Okay. I'm looking at everything right now. It looks good except for the A and the C have issues. Both of those have negative exponents. We're not allowed to simplify and say we're done until we fixed the negative exponents. Negative exponents need to be moved. If it's a negative exponent, as we see it here, we need to put it on the bottom of the fraction. So our numerator is going to be 3b to the 7th, the positive exponent and the coefficient. And then on the bottom, we shifted a and c, because they were both negatives, down to the bottom. A to the 6th, c to the 8th. They're no longer negatives because they've been moved down to the bottom of the fraction. Our final result is 3b to the 7th divided by a to the 6th, c to the 8th. Not too hard, is it? We got this. Now, let's use our power rule first. Then we'll use our quotient rule, and if we end up with any negatives, we will take care of them. Or if we end up with any zero exponents, we'll turn them into 1, which technically makes them disappear. So I'm going to distribute this 2 to the 3, the 8, the m, the 0, the 5. That 2 is outside of the parentheses. It needs to distribute using the power rule to each part, each factor of this expression. So now I'm also going to bring that 2 down to the 5, the 4, the v, and the 2. It goes to all of those sections. So let's go one by one. Into the third, 3 times 2 gives me into the 6th. V to the 8th, I take the 8 and I multiply it by the 2. I now have V to the 16th. M does not have anything above it. Technically there's a 1, so 1 times 2 is going to give me M squared. R to the 0 power, that 0 needs to be multiplied by the 2, and 0 times anything is 0, so we're going to write R to the 0 power. Q to the 5th, I need to take that 5, multiply it by my 2. And now I go and take care of the bottom. The 2 and the 2 multiply together to make n to the 4th. The v does not have anything. It's a 1, so v to the 2nd now. 4 times 2 is going to give me a 8. Q to the 5th, also to the power of 2. That 5 and that 2 are going to multiply together and make a 10. And now that we've done the power rule, we use our quotient rule, which is what you are learning in this video here. If we have matching variables, we want to subtract the exponents. 6 minus 4 gives me n squared. 16 minus 2 is going to give me v to the 14th. 2 minus 8 is going to give me m to the negative 6th. R to the 0 stays R to the 0. Q to the 10th and Q to the 10th is going to give me Q to the 0 power. Okay, now what do I want to do with these zeros? Anything to the 0 power is a 1. So if I were to multiply all this information times a 1 and a negative, another 1, is it going to change the information at all? No. So what do I want to do with them? To them, I want to say, never mind. See what I did there? All right. Now we have one more step. N squared v to the 14th and m to the negative 6. That negative 6 cannot be there. I need to move it to the bottom. So my final result is, nice and big, n squared v to the 14th over m to the 6th. And that would be your final result for this problem. Hopefully this all makes sense. If you have any questions whatsoever about the quotient rule and then how we use it in lengthier problems, please leave a comment and I will get back to you, helping you out with whatever it is that you need. Thank you all and good luck on your upcoming test.